Welcome to College Algebra. In this lecture video, I'm going to trace back talking about the matrix operations that I skipped it in the previous video. So again, I apologize. Didn't notice I was skipping this topic. All right. So what we want to do here is take a look at how we can add, subtract, and multiply our matrix. Okay. So the first one is called the matrix addition and subtraction. Matrices of the same order can be added or subtracted. So the formula is telling us if I take matrix A plus matrix B, the way how we add them is go by the IJ entry. Okay, so the AIJ, for example, like the 1-1 entry from matrix A will add on to the 1-1 entry for matrix B. Same idea for the matrix subtraction. All right, so I'm going to put this in the calculator just in a minute, but this particular example saying want me to find A plus B plus C. Okay, so when we add and subtract, we go by the entries. So if I take matrix A, the 1-1 entry, add on to the matrix B 1-1 entry, -4 plus 7 will be 3. And 3 plus the matrix C 1-1 entry will be -5. So remember now, my 1-1 entry will end up to be -5. Okay, gotta be the same order in order to actually add them or subtract them. Makes sense because I'm adding and subtract them by the what? By the entry. So you gotta be the same order. All right, so I got 3 row by 2 columns. So I'm gonna go to my matrix, go to edit. Okay, 3 by 2 entry. So I'm just gonna key it in -4, 1, 6, -7, and 0. Okay, I'm gonna get out, go back in, go back to edit, and go to my matrix B. 3 by 2. 7, 10, -1, -5, -7, and 4. Okay, once I key it in, get out, go back in to edit the third one. Okay, another 3 by 2, -8, 6, -4, 9. Okay, so once I get done, go to quit, second matrix, go back in, and under names just say matrix A plus, go back in to matrix B plus, go back in matrix C. Okay, a little bit of work. See, that's the same -5 right there. So that will be my answer once I add them all up. All right, now matrix, it also consists of scalar multiplication. Okay, so scalar multiplication means if I have a matrix, okay, I can actually have multiples. Okay, scalar multiplication, I can have a constant C in, that can multiply my matrix A. So that constant C will multiply all the entries within my matrix A, C times AIJ entry. So this problem, for example, 3 times my matrix A, scalar multiplication. So 3 times my matrix A, that means I will multiply, okay, every one of my entry by 3. So that will be -15. 3 times 7 is 21. 15, 6, 6, and -18. That's all it is. Okay, it's called scalar multiplication. And I can, times a half, but make sure this is a real number that you're using to multiply the matrix. All right. Determine, if possible, determine 4A minus 4B. So when I do my scalar multiplication, my order does not change. So when I take 4 times my matrix A, order does not change. 4 times my matrix B, order does not change. So how can it not possible to subtract or add when orders are different. So initially what I'm looking at here is make sure my two matrices are the same order before I will add them or subtract them. Okay, so this is a 2 row by 1 column. So I'm gonna go to the matrix and put this in the calculator. 2 row by 1 column. Okay, that will be 4, 5. Get out, go back in, edit, go to B. 2 by 1, 5 and 5. Okay, get out. So now I'm gonna do 4 times my matrix A minus 4 times my matrix B. There you go. That's my answer. -4 and 0. Alright. Now, when it comes to multiplication of matrix, okay, this is just a definition of a 2 by 2 matrix that being multiplied. Couple of things to keep in mind, okay? Matrix A is this one, matrix B is this one. So the way how we multiply is go by row times column. When I take matrix A times matrix B, I take the row, okay, excuse me, I take the rows of the matrix A times the first column of matrix B. So that will be A times E plus, okay, B times G. So think about what I just did. I took the first row times the first column. So that will give me the 1, 1 entry. Okay. So when I take the first row times the second column, that will be, the answer will locate it at the 1, 2 entry, which is first row, second column. Okay, and that's the way how we actually, that's the way how the calculators actually compute this. All right. Now, in order for 2 matrix to multiply, okay, right now I got a 2 by 2 matrix, need to multiply a 2 by 2 matrix. Okay, for the row time column to work, you got to make sure these 2 inner numbers are exactly the same before you actually multiply them. Okay, so that's how sometimes, you know, it's not possible to multiply. So check this one out. This is matrix A. Matrix A is 1 row by 3 column. Matrix B is 3 rows by 1 column. So when these 2 numbers are the same, I am able to multiply them. Okay, and so I'm going to show you how to do what A times B is. Okay, so I'm going to go edit. This is 1 by 3, 5, 0, -9. Alright, get out, go back in, under edit, go to matrix B, and let's do 3 rows by 1 column, -7, 5 and 1. Okay, I'm gonna get out, go back in, and pick matrix A times matrix B. Okay, that's my answer. Just -44. Okay, row by column. Okay, otherwise you just give me that answer, and I only gonna end up with 1 answer. Alright, so how do they do it? First row times first column. First row times first column only give me 1, 1 entry. So that will be 5 times that, plus this times that, plus this times that. Okay, just like what the formula shows up here. Alright, now vice versa. I'm going to do matrix B times matrix A. And you will find the answer is different. Okay, can I do that? Can I take matrix B, which was a 3, 1 entry, 3 row by 1 column, and multiply 1 row by 3 columns? See, as long as these 2 inner numbers are the same, I am able to multiply them. So this time, this will be my answer. So as you can see, A times B is definitely different than B times A. Okay, so matrix, okay, when we talk about matrix multiplication, it does not have commutative property. Okay, it does not have commutative property. A times B is not the same as what? Matrix B times matrix A. Okay, does not have commutative property. Alright. So this is 3 rows by 1 column. This is 1 row by 3 columns. So I can actually multiply. Okay, I'm not going to do it, but just make sure we can actually multiply. Alright, check it out. This one, this is a 2 row by 2 column. And this is 1 row by 2 columns. So when these two numbers is not the same, you actually cannot multiply them. So this one would be not possible to multiply. Alright, so just real quick, kind of briefly talk to you about how we can add, subtract, and multiply our two matrices. Okay, so this will end our chapter 10 lecture video series. Thank you for watching.